So in a single slit diffraction experiment, first minimum for lambda 1 equal to 660 nanometers means coincides with first maximum for wavelength of lambda 2. Now what is the case? Now here, if this is a slit of slit width A, let me write here, of slit width A, on this a monochromatic light of wavelength lambda 1 is equal to 660 nanometers is incident. Then what will happen? It undergoes diffraction. If this condition is satisfied, lambda is proportional to A, lambda is nearly equal to A, it undergoes diffraction, and on screen you will get central maximum. So if this is the central maximum will be symmetric about this line, that is line passing through a midpoint, it will be symmetric. Now this is the case. Okay, now what happened? First minimum in a single slit diffraction experiment, first minimum for lambda 1 equals 660 nanometer coincide with first maximum for wavelength. Now on this slit I incident one more other light whose wavelength is lambda 2. When I incident this light, what happened? At this point what happened? First maxima is formed. That means case will be like this. That is, here I will get central maximum, then this will be my first minimum, then this will be my first maximum. Similarly here also, this will be my first minimum, this will be my first maximum. So when I incident a light of wavelength lambda equal to 660 nanometers, at this point I got central maximum, and that is the first minimum. If I replace this lambda 1 light, this light with other light whose wavelength is lambda 2, then at that point I got first maximum. Now we have to calculate lambda 2. What is the value of lambda 2? Already the value of lambda 1 is given as 660 nanometers. Now once again I am saying this is related to lambda 1. Similarly, this is related to lambda 2. Now let us think about lambda 1. So for both cases this distance is same. That is, if I take this as y, in the case of lambda 1 it is y, in the case of lambda 2 also it is y. This distance is also fixed in both cases, that is capital D. There is nothing but distance between slit and screen is fixed. Then if I draw a line to my point of observation, then what happens? This angle will also be same. Since y and d are same, then this angle will also be same. Okay, now let us think about lambda 1. The condition to get first minimum is a sin theta is equal to lambda. Okay, a sin theta equal to lambda. Now okay, so now let us go to the second case, where second case means related to lambda 2. In the case of light related to wavelength lambda 2, we got first maxima. Now the condition to get first maxima is a sin theta. Here also I am writing theta. Why? Because in both cases my y is same. That is, in both cases my sin theta is same, and a is also same. A sin theta is equal to, condition to get first maxima is 3 lambda. This is lambda 1, no? Lambda 2 by 2. Okay, now that is 3 lambda. Now I can write this a sin theta as lambda 1. That is, lambda 1 is equal to 3 lambda 2 by 2. Then lambda 2 will be equal to 2 by 3 times of lambda 1. That is equal to 2 by 3 into 660. That is 220. That is equal to 440 nanometers. So the wavelength of this light should be equal to 440 nanometers, such that at this point I'll get first maximum.